we're going to recall how to do regular substitution, and then I'm going to teach you guys a new way to do it called synthetic substitution. Now, it's not vital that you understand this synthetic method for the substitution, but what it's going to help with later is being able to divide polynomials so that we can factor like third or fourth or fifth degree polynomials, because at this point the only thing you've ever factored were things that factored nicely and mostly squared polynomials. But let's remember how to do direct substitution. So if we're trying to find f of 2 for this polynomial, that's what f of 2 means. It means we're plugging in to every single place that we see an x. So instead of f of x, this is your function notation. We're going to say the function when the value 2 is substituted in equals -3 times 2 cubed plus 2 squared minus 12 times 2 minus 5. And then we'll just simplify. So 2 cubed is 8, so you get -3 times 8 plus 4. 12 times 2 is 24 minus 5. So then we get -24, and then -4 plus, no, minus, or 4 minus 24 is -20, and -5 is -25. So -24 and -25 gives us -49. So we can say that our function, when 2 is substituted in, so f of 2 equals -49. So that's the way you guys have always substituted values in the past. So I'm going to teach you guys, or show you guys, a new method. So the x value that you're substituting in, so we substituted in 2. That goes on the outside of this L-shaped box here. So the value you're dividing by always goes on the outside. Then you take the coefficients, this is really a 1, in front, and your constant through your whole equation. Now you have to make sure that every place value is being used. So in this problem, we do have every place. It starts at a cubed, which means if it starts with a cubed, it needs a cubed, a squared, a first, and a constant. And it does. It has the cubed, the squared, the first, even though we don't write first, and your constant. So we just take the numbers out in front. 3, 1, -12, and -5. So once you get used to this, you will like it. It's just something new you've never seen before. So what happens is we bring down the first value. And that's going to go on the outside of our box. And then we just multiply and add and multiply and add and multiply and add. So we multiply 2 times -3 and get -6. We add those two values. Then we multiply your outside number by what you have left. Get -10. Add those two values. -22. Multiply that by 2. -44. Add your two values, and if you'll notice, we got the same thing that we got above. We plugged in 2 into our function, and we got out -49. So whatever this last number is what your expression or your equation equals for that given x value. So for right now, you can use both methods, but you'll have to know how to use this synthetic method when we get further into the unit. So let's just do one more to try to get a hang of it. So we're substituting in -3. So I know that that's going to go on my outside. And I'll just draw my box. Now what we have to be careful with here, guys, is we're starting at a 4th degree, which means we need a 4th, a 3rd, a squared, a 1st, and a constant. So it goes 4, 3, 1. So we don't have a squared term, and then we don't have a constant. So I'm just going to rewrite this in order so that you guys can see what's missing. So we have our 4th degree, our 3rd degree, we need our squared, then we have our x to the 1st, and then we need our constant. So now every single place value has a value. It might be 0, but that's okay. So what's in front of your x to the 4th? A 1. So 1, what's in front of your x cubed? -2. So you do bring the negatives down if there are negatives or minuses up in your equation. And then a 0, and then 4, and then 0 again. So the first number you just bring down. Then you multiply and add and multiply and add. So -3 times 1, add to get -5. -3 times -5, 15, add 15. -3, we get -45. And then you add those guys together, get -41. And -41 times -3 is a positive 123. So if you would have taken -3 and directly substituted it in for all your xy's, you should have gotten the same thing. So we can say, and our function is an h of x, that's just function notation, we're just calling it an h function. So we'll say h of -3, when you plug -3 into that equation, you come out with the value 123. So you always bring down that first value, but then after that, it's just a matter of multiplying and adding for however many place values you might end up having.